Let's look at an example. Let's compute the third line of the truth table for the formula P implies Q or R implies R implies not P. The third line for P, Q, R will be T, F, T. So let's break this formula down into a tree structure to make it easier. At the root node we have implies, and to the left of that we have P. To the right of that we have another implies. To the left is an OR. To the right is yet another implies. To the left of the OR is a Q. To the right of the OR is an R. To the left of the last implies is an R. To the right is a not, with a P underneath. So if we start filling in values, we see that the P's are true. And the R's are true. And the Q is false. So this not is false. And because the antecedent of this implies is true, and the consequent is false, this implies is false. But then since this implies is false, that makes this implies true by default, because the consequent of the implies is false. But if we were to compute the truth value of the OR anyway, we see that the Q is false, but the R is true, so the value of this OR is true. Looking at the root node, we see that P is true, implies true. So true implies true is true. So this statement is true for the third line of the truth table. Try computing the remaining lines of the truth table before we go over them in the next video.